Good morning and a warm welcome to today's distinguished lecture on creating a more inclusive future, exploiting the intersection of artificial intelligence and human bias. My name is Shaukat Ali Khan, and I am the Chief Information Officer at the University of Central Asia. I'm delighted to be the moderator of this distinguished lecture today. Our today's speaker is Steve Krohn, Vice President and Deputy General Counsel, Human Rights at Microsoft Corporation. As a member of Microsoft's UN Affairs team, Steve works closely with colleagues at Microsoft and with external parties across the globe to advance company, industry, and multi-stakeholder initiatives, including through public-private partnerships. Since joining Microsoft in 1997, Steve has led legal and policy teams responsible for the Windows client, Xbox and entertainment, and Office businesses, as well as legal strategy for China. He is a member of the World Economic Forum, Global Futures Council on Human Rights and Technology, and the Partnership on AI. He serves in leadership positions at a range of organizations, including the Seattle Metropolitan Chamber, past Chair Executive Committee, the Global Network Initiative Executive Committee, the International Bar Association, Media Law Executive Committee, the American Society of International Law Executive Council, and the US-Russia Business Council as a board member. Steve holds degrees from the University of Washington, the University of Oxford, and Yale Law School. Please welcome Steve Krohn.
Well, thank you. I'll try to share my screen. Oops. Well, I have to go back into Zoom to share the screen, apparently. Did that work?
Yes.
Yes.
Okay, excellent. Well, let's get started. The plan is for about 30 minutes of my comments, and then I hope there will be question and answer. So I hope I do spark some questions, but let's get started. First, thank you for this invitation to speak to the university community. It's an honor and a great pleasure to share some thoughts with you. As you can tell, I am from Microsoft, and that very much informs the way that I think about today's topic. But in this talk, what I will share will be primarily my personal experiences and opinions. At Microsoft, we approach all of our work, but especially our work on artificial intelligence, or AI, from the perspective that at the most fundamental level, our success as a company is tied to the success of our customers and the world around us. Our mission statement is to empower every person in every organization on the planet to achieve more. So we actually believe that the reason we exist is to help solve the world's problems. We're driven as employees to provide solutions to the challenges of people and increasingly of the planet. That's the way I approach the challenge of AI and bias. So I'll talk briefly about three things today: what AI is, bringing bias into the light, and then using bias to improve AI. I'll propose that we use bias as an aid, as a force to be managed. And so let's go dive in. What is AI? I'll provide a very brief introduction, but I found in many talks this is helpful for the later comments and the question and answer. This is oversimplified. So in line with our talk today, it's heavily biased, but let me see if this helps people ground themselves in what we're talking about. The field of artificial intelligence has been around since the middle of the last century, but it has experienced explosive growth.
Steve, sorry to interrupt. We can only see your UCA Distinguished Lecture Series screen. Yeah, we see.
That's all right. I haven't moved on yet. I'm still in the introduction. All right. So let me go back to. There's been explosive growth in AI in the last decade, and there are three developments that made that possible. First, there were advances in computer storage and retrieval technologies. This led to immense growth in digital data. In the last 2 years, we human beings have generated more data than we did in our entire prior history. We now measure data growth in zettabytes. For you mathematicians, that's sextillions of bytes, 10 to the power of 21. Across the planet, we've created and stored over 70 zettabytes of data, and third parties expect that to grow by over 100 to 175 zettabytes by 2025. The second development was innovations in computer hardware to capture and make use of that data. And finally, there's accelerated improvement of specialized computer software. This is especially powerful in that it works in a virtuous cycle with advances in computer hardware. So that's generally how we got here. Now I want to talk about why we call it artificial intelligence and what that is. The idea here is that we are creating machines that think like human beings. And we mean that almost literally, not entirely, but almost literally. And one of the most widely discussed forms of AI is neural networks, which are based on biological studies of the human brain. In our brain, thinking happens at the level of neurons, somewhere on the order of 100 billion of them working in tandem. Now, this picture of neurons might look confusing and pretty unhelpful, but computer scientists were able to build on the following simpler model of what happens inside the human brain. In creating artificial intelligence, the idea was to take the idea of dendrites. You see those at the left-hand side of the slide. These are electrical signals that the brain cells receive from others in front of them. Then there's soma in the middle, the processing in the big part of the slide. And then those are sent out as on axons, but these are weighted new electrical biological signals that are picked up at their terminals at the far right by the dendrites of other neurons. So the idea is you receive something, you process it, you put an output, it's repeated. This is what happens in an artificial neural network. So what we're doing is we're mimicking as best we can in silicon and chips and computers, one model of what happens in the human brain. Of course, with a computer, you're starting with zeros and ones, digital inputs, but then with mathematical calculations, feeding signals and weights, the idea of the likelihood from the left to the right, moving through these hidden layers. Finally, the machine is able to deliver an estimation. Typically, it's of how well one pattern matches another, or the probability that what's in an input layer corresponds with any of the options that were preset as available in the output layer. And most AI today, for that reason, is designed to respond to a narrow question or a narrow set of questions. But AI has proved especially powerful in tasks like natural language processing. I can go on the internet and put in a Russian text and get a very accurate English language translation, or vice versa. We see people using this every day. It's instantaneous, highly accurate. But AI has also proved amazingly powerful at object recognition. And think of what a computer needs to do. All it's receiving are the zeros and ones that are on a digital copy of a photograph. But we're asking it to identify whether in that collection of zeros and ones, there's an image that is equivalent or similar to an item that it's been trained to recognize. So we might ask it to identify, is there an object in this set of pixels? And is it a tree or a flower? Can it distinguish a dog from a cat, a bicycle from a motorcycle? And machines have become incredibly competent at doing this. And they get to do that because there are thousands or even millions of samples that we tag. We tell the machine what this is. And then when it gets a new image, it tries to figure out what's the best way of matching it is or isn't like the image it was trained to look for. But object recognition is not foolproof. And we know that it provides some risk. Now, one special area of object recognition is a field called facial recognition. With facial recognition, we decide to go more focused. We instruct the machine to assess whether an input image is similar to an image it's been trained to associate with an image of a human face. So the machine generates an estimation of probability. This, of course, is oversimplified, but you'll see at the top of the slide the idea early in the process. It's just picking out various things from the image that might or might not be relevant to the kinds of things that have been identified in human faces. Then it might go in the middle layer to looking at more and more samples of that put together. And finally, on the right, it would look at, is it now a human face? And then it will go further to try to identify that if we ask it to. Of course, there would be many more layers than just the 5 that are shown here. And the process could be iterative. It'll cycle through looking for increased accuracy and pattern matching. So with that, let me turn to bias and why I brought that into this conversation. Let's start with some dictionary definitions. So very often people think of bias only in the most negative terms. I took things from the Oxford English dictionaries. So in the one that I have in my office, a hardbound from the 1970s, the primary definition is unfavorably inclined. You'll see other things here where it has to do with prejudice or feeling against somebody. But that's not the only definition of bias. Bias is also this one that I've entered now, this concentration on or interest in a particular area or subject. And that's the kind of bias, whoops, I'm gonna go ahead. That's the kind of bias that I'd like us to talk about today. Because typically computer scientists, the engineers who are building these, they're not in fact filled with bad intentions or desire to be unfair, but it is a challenge that data scientists, anytime they want to work with a machine, must select some and omit other data from the system. And as we know, there's virtually an infinite amount of data potentially available to us in the cosmos, but only some of that has been reduced to data that a machine can read. So the goal of an AI system, as we've seen, is to focus on answering questions, working with the most relevant data available to us. And we have a bias. We want signals, things that are likely to help the machine rather than noise that might simply confuse it. And I'll return to this later in my talk toward the end about the challenge that this presents for human interactions with AI systems. The idea that we can eliminate bias might be misguided, but we can ask questions to determine how we're addressing this risk of bias entering machines. So again, on the idea of training a machine, we feed it massive numbers of images. Each is annotated by a human being to help the machine establish a baseline for the things that it should look for. And with enough images, a really good object recognition will, without any further human coding intervention, improve its predictions over time. It'll do this through trial and error, again, without any human interaction other than to validate that, yes, this is a better response than you had before in matching what we're looking for. So I'd like to stay for a second with this idea of facial recognition, because it does help us tease out some of the ways that bias affects performance in AI and what we should be watching for. Beyond that simple task of simply identifying, is there an image that contains a human face? One thing we often ask computers to do is answer the harder question that requires it to distinguish between or among human faces. And now we turn to other sorts of data that can be extracted from a particular human face. Not just things like, is there an ear, is there a nose, but what are the geometric measurements across the face? Features like eyes, foreheads, cheeks, chins, height from the chin to the scalp. And we can ask the machine, is this an image of a male or a female? It turns out that even for this very simple question, facial recognition systems continually deliver different degrees of accuracy across different populations. On this slide, what matters is not the actual numbers. If you can't read those, I want you to look at the middle two columns. You see what happens there. These are old data. We're much better at this than we were, but you'll see that for darker females versus lighter males, an incredible difference in the competence, the ability and accuracy of a machine to get a correct answer, one that we validate as correct. And even though now in calendar year 2021, we're well beyond the numbers that we're in here, there's still this difference between especially darker female and lighter male faces. And again, I want to emphasize the bias here is not because of intentional wrongdoing. It probably relates especially to numbers and qualities of images that are in training data sets. It turns out that many image data sets of human faces are skewed toward lighter complexions. This is certainly true in the part of the world where AI research and development is most intense. Some data sets include more men than women. And we can understand how this might be. Mass media and public discussions can easily devote more attention to some groups than to others, and that then is pulled into the data sources that are available for training AI. So what are we to do? At Microsoft, we're tackling this challenge as part of a commitment that we have called human-centered AI, really making sure that the human being is at the center of everything we do as we think about AI systems. How do we make sure that they actually enhance the human condition? So we have in mind goals like increasing equality and equity, that is fairness, and not discriminating in harmful ways. Of course, we want to reduce bias. We'd rather have no bias, but there may be limits for the reasons I noted as to what we can achieve there. So I approach this challenge not primarily as a computer scientist. I'm not a computer scientist, but from a broader ethical and human rights perspective. I noted earlier, I've come to believe that bias pervades all human experience. The simplest illustration I have is that it is what we human beings have been forced to do. We focus on the things that we believe are relevant, and that's driven largely by our evolutionary biology. Our brains can process only the inputs they receive, and we human beings are amazingly limited in our sensory capacities. For example, our eyes can only see certain wavelengths of light. Our ears can only hear certain frequencies. In our daily lives, we pay more attention to things at a human scale than we do at the microscopic scale. Now, this inevitably carries over into the data that we collect and what we digitize, store, and then make available for viewing and later analysis. So I go further. Our language itself reflects bias. I'm quite conscious that every word I choose emphasizes some dimension of an idea over another. A bit of a digression. I'm a lawyer, but I studied history and literature before I studied law. And I know that the description of any human experience sets forth only part of a story. Out of all the possible statements about an experience or an event in history, we pick only a select few, a very skewed sample. And this challenge always brings to my mind an incredible line from the Russian poet Fyodor Tyutchev, "Мысль изреченная есть ложь." That is, a thought put into words, once we utter it, becomes a lie. And I could not resist, and I hope this particular audience will forgive me, but I thought, sorry. Oh, he's missing from it. I have a photo I intended to include of Fyodor Ivanich himself. I figured it was the only time that Mr. Tyutchev would appear in a lecture on artificial intelligence. But building on this idea that no utterance or model captures all of reality, I don't think we'll ever fully eliminate bias from our human creations, including AI. So I want to encourage us to think how we can use attention and data biases positively in ways that can help us manage AI. I'm reminded in this regard of the facetious lament, the complaint, that darn gravity, it's everywhere. And I think we actually should think of bias as a force rather like gravity. For us humans, even though sometimes we might wish we could be free of it, we've learned to live with the fact that gravity is everywhere. And when concentrated, gravity is an incredibly powerful force. Let me just note, it's the force behind black holes. Considering gravity at that scale, it's hard to think of a more destructive force. It's literally able to rip to pieces and consume entire stars that are larger than our sun. This is a picture from NASA, the US space agency, showing a star being pulled into a black hole. The star is at the upper right, and it's being pulled in and swallowed up, literally consumed by a black hole. But even at a much smaller scale, gravity is the force behind avalanches, floods, other disasters we encounter here on Earth. And then I want to reflect on the fact that that's not the whole story. Yes, there are powerful forces, but forces can be exploited. Gravity can be harnessed. Think of hydroelectric power. We harness the force of gravity to channel and then accelerate water, to spin turbines that then generate electrical power. We have similar opportunities, I want to suggest, with biases in artificial intelligence. Maybe like gravity, though we wish we could be free of it, we would be better served by learning to make bias work for us. While never making peace with biases that support wrongful discrimination, maybe we should think about how to use other forms of bias. Maybe it's enough if we think more clearly about how to identify biases in artificial intelligence. How do we bring them into the light? And how do we accept the need to manage them? I have a couple of examples from this, and all of this flows from concern really about fairness and inclusion, making AI empower all of us, not just the most advantaged. Microsoft's published a variety of guidelines and tools for the world to use as we look at this challenge. Oh, there was Mr. Tushev there. So I just grabbed a screenshot here of some of the guidelines that we've published. We refer to it as responsible AI. It's this notion of rights-respecting, human-centered AI. And what are some guidelines that people across the globe should be using? So we look at, does it have a greater tendency to focus on issues like race or gender, marital status, or ethnic background? And I invite you to look at out on the web at Microsoft's work on responsible AI. You'll find an open source program called FairLearn. And FairLearn is software that we make available free to the entire globe for people to uncover what's happening inside AI software, to look for biases. Now, we're a core and engineering company at Microsoft, so we believe in processes and structures. And with AI, we've found that we're interacting every day more directly with social and ethical concerns, not just in the United States, but across the globe. So we've created internal structures to bring executive leadership and discipline to our work on these challenges. And being Microsoft, we love acronyms, that is making words out of the first letter of a series of words. And I'll mention just two. We have a group called RAISE, R-A-I-S-E, which was really a reflection of responsible AI strategy in engineering. We have another committee called the Ether Committee, AI ethics and effects in engineering and research. And in these, we take people with broad disciplines across the company, but especially with a focus on the engineering work that happens to make sure that we're identifying and then addressing and remediating bias. I encourage you also to look at work that we have published as well from our FATE initiative, F-A-T-E, which stands for Fairness, Accountability, Transparency, and Ethics in AI. These are publicly available documents, and I encourage you to take a look at those if you're interested in these questions. There are research papers like Mitigating Bias in Algorithmic Hiring, looking at how AI can influence the opportunity for people to get the jobs that they are qualified to do, but might be eliminated from consideration by an AI machine. And I recommend all these resources, not because they're perfect, but because I think they point in the right direction. Now, I know that most of you are not computer scientists. I mentioned I'm not a computer scientist, but we can all appreciate that AI is a human creation. And we know, as I've described, that human beings determine what data is fed into an AI system. And the data that we provide always betrays some selection, some skewing, some bias. So when we think about this, we need to be especially attentive to what biases, with the best of intentions, people might nonetheless have let creep into the data we use inside these machines. But I want to propose that if we can manage something as powerful as gravity, which can generate things as unimaginably powerful as black holes, we should be able to make progress in working with human bias. So let me give you a quick example, one that I think really illustrates this in a great way. Microsoft has an application. I have it downloaded on my phone. You can find it out on the web. It's called Seeing AI, seeing in the sense of visually seeing. So Seeing AI is a service that is intended for someone who needs assistance because they have limited vision. And the way it works is they take their phone, they point it at a scene or at a small short text like a sign or a menu. They take a video or shoot a picture, and the AI then locally can help identify what's in the image using object recognition, as we described, or facial recognition. And you can find great video of one of the app's creators, Shakib, a colleague in London. He was one of the people behind the creation of this. Himself, as you see, is visually impaired. And he actually uses it as he's making his way across London in a day to demonstrate the capabilities of the technology. But here's what I want to point out, not just because it's one of my favorite examples of AI empowering human beings, but I want to turn to the training set for AI. This was created by people with the best of intentions, but it turns out that the training data used to build Seeing AI demonstrated a bias. And that was a bias for images that were well focused, they had good lighting, and they directed attention toward the center of the picture. And when you think about it, is that likely to be representative of most of the pictures that are going to be taken by people who don't see well, if at all? And so we have these biases that creep in. They're not ill-intentioned, but they are things we need to think about, because once we identified that, then of course we could change what was being fed into the machine and the performance of the machine. So my lesson here, and I have only a few more minutes that I wanted to speak with you before taking questions. We all need to think about being more inclusive in all that we do with AI, all the way from its creation to its actual use. And bias is more than just data sets. It's the people behind the machines. Who's actually asking the questions that we're asking AI to solve? What are the challenges that we think are most important? And what outputs do we think are going to be most useful to us actually to address real human problems? Now, Microsoft's not alone in taking steps to make AI more human-centric. And the vocabulary changes. It changes across companies, across countries, across specific audiences. Sometimes in my talks, I'll talk about AI ethics. Sometimes I'll talk about AI and human rights. You just heard we sometimes refer to it inside Microsoft as responsible AI. But in all instances, what I want to emphasize is what's most important is to keep this notion of inclusion and fairness, human dignity and empowerment at the very front of our attention. Now, I won't dive into these, but for anyone interested, I definitely direct your attention to the AI principles that Microsoft published back in 2018. What I find interesting here, in light of what we just have been talking about, we worked hard to limit ourselves and got it down to just 6 principles. But you'll see even under that very strict constraint, requirements for fairness and inclusiveness rose to the top. Our experience is that those challenges of bias will not be addressed effectively unless all of us work together to increase transparency, the intelligibility of AI. You see that in the next to the bottom. We think that's a foundational building block for solving these things above it. And ultimately, you'll see at the very bottom of the slide, this idea that we need to hold human beings accountable for what they build and the way the systems work. So with that, I'll conclude by asking that as you increase your exposure to AI, please think about paying attention to what you see and especially what you do not see, what is missing. Because I believe bias accompanies specific choices about data sets and the questions we direct AI to tackle. And this question of bias and inclusiveness matters. It'll matter increasingly, I believe, to everyone in this audience as your countries and your societies and the places where you work move up the curve of digital transformation, using AI to become more efficient and to drive better decision making. We already know that AI plays important, very often hidden roles in the allocation, and most concerning, it can also play a role in the withholding of resources and opportunities. So AI machines are already performing risk analyses that affect banks' credit and loan decisions. They're used by companies as they make hiring decisions. They're being used by governments in ways that can affect wellness and the safety of citizens. We believe as Microsoft that AI can be especially helpful in all of these scenarios, but in every deployment of AI, we need to focus on fairness, human dignity, and respect. So with that, when you think about AI systems, be thoughtful about questioning what perspectives, what assumptions about relevant data, what biases might be affecting its performance. And by the way, it's not enough to think about what data sets were used to train an AI system. We need to question what data is being input into the system when it's out in the real world. It might be trained with a really good data set, but then over time learn to optimize for poorer, less inclusive data that's being used as the machine refines itself. So we at Microsoft, I'll conclude, we believe AI is the most powerful technology humankind has ever created. We see where it's headed. We find that exhilarating, but it's humbling too, in that we know also that we don't know all the questions we should be asking. And that's why I'm delighted to give talks like this one, bringing other people into that conversation. We at Microsoft have concluded with great confidence that it's by paying attention to all of the workings of AI, from initial design to review and real world inputs and outputs, that we stand the best chance of harnessing AI to enhance human dignity and opportunity. Finally, I'll just say that this challenge reaches well beyond universities and technology companies. It is a challenge for the entire human community, and we all have a role to play in this. So thank you, and I hope this talk has sparked some questions we can explore together. Thank you.
Thank you very much, Steve, for a very, very interesting and exciting presentation, and a lot of interesting facts. We have a couple of questions, but before asking the questions, I would also ask all the attendees, if you have any question from the presentation, then please just put your question in the Q&A section, and all the attendees who are watching us on social media, just put your questions on the comment field there. So we will take 3 or 4 questions in total because of the time, but let me just start. So Steve, one of the question is, what are the general challenges you see in bias AI? Because there are people who are also confused between the AI and then the privacy part of it. So how you deal with that?
Yeah, I view bias and privacy as separate but related challenges. The bias is what I was talking about in this talk, and that's the idea of we enter in data that reflects certain additional data about some populations than others. One of the ways actually that people have tried to get around this problem is to say, well, let me go out on the internet and grab lots more images and lots more content. And because it's on the internet, I'll use it to improve my AI, but without giving consideration to the privacy consequences of that. Normally, we want consent before our image is used. We want to be able to choose how something we have said or written is used, rather than having somebody simply scrape it from the web and then use it in a way we might not approve of. So it's a related challenge where there's a lot of work that happens in the AI research community on this issue of privacy. And then there's also the issue, separate from the way the machine is working, the outputs of it, we start to worry about our privacy when we think a machine is taking all of this data about us from all sorts of sources and then determining things about it that we never intended to share with anyone else. There are lots of apocryphal stories of even psychologists who say that using tools that are related to, for example, what might be out in somebody's Facebook content, using that in an AI solution, they can learn more about the person than the spouse might recognize about that person on a particular question. And so there's this dimension of privacy too. I personally, as both a lawyer and somebody in technology, and as an American who's concerned about privacy, I have this question about how we're defining privacy in the modern world. Very often, in my view, what we really want is practical anonymity. That is, we don't want people to identify us as a unique human being with particular things we said or did at a particular time. And in the world 100 years ago, so back at the turn of the last century, nobody was worried that people were going to be able to track every place they walked and every conversation they had, and identified by picture everyone with whom they met in a given day. And if that happens out in the public sphere, it's happening on streets and at the entrances to restaurants where there are cameras that are capturing all of this. It's not that it's a violation of privacy that I expected that all to be secret. It's that I didn't expect it to be collected and used in a particular way. And I think there's a large debate that we need to have about appropriate uses that are in part grounded in that concern of privacy.
Thank you, Steve. It's interesting. We have a question from our audience. They're asking, do you think AI can write books that will be as fascinating as a genuine writer ones? When, if at all, do you see time when humans won't be able to notice difference between human and AI written novels?
Yeah, so I try generally to avoid making scientific, kind of science fiction predictions. The tech industry has been really bad at that over the years. What I will say is there are already things that point in that direction. You can find out on the internet things that are written by AI taking a number, for example, if it grabs all of the news stories or a big selection of news stories from a newspaper, it can put together its version of a story for the day that might sound entirely plausible as written by a human being. The language, because of this natural language processing, we're getting really good there. What's harder is to capture the human creativity. There are things you can find on the internet of people who are asking AI to write music, to write poems, to take a poem and put it into music, or to describe what's happening. That will get better over the years, especially as I mentioned, as data continues to explode, as more and more data is fed into natural language processing and more languages and translations, because we all know if you speak another language, there are things you think in one language that isn't quite the same as in another. A machine will be able to know all of the human languages at a very high level. So I think it will make progress in that direction. I don't know when that will be. And I don't think we're working in a way that's going to lead to that in the near term, but I know better than to try to guess what year that would be or even what decade.
Thank you, Steve. We have another question on our social media. How is the safety issues are going to be tackled in education sphere, especially with the involvement and interaction of children?
Yeah. So on that one, I don't think we as Microsoft have an answer to that. We have some of the questions that need to be asked, and those are the things I touched on here, but also who is determining what information should be taught in what way, with what lessons to children. And that we differ on that across societies already on the planet. So thinking that AI is going to do a better job than we do is probably misguided. It's going to be really, how do we make AI serve as a tool to our educators as we bring it into that work? I think we're already facing that. People note in the United States, especially, we now have two generations. My children who are now in their 30s, they belong to the generation where they grew up with digital technology, but it wasn't the primary way they engaged. There's a new generation, maybe 15, 16 and younger, where they grew up and they are digital natives. I mean, their world has been defined by this digital experience in a way that I can't comprehend, in a way that's foreign to even what my children probably would experience. And they, by the way, are only at this edge early in the 21st century. What is it going to be in 50 or 100 years as more generations come along? I think what we need to be thinking about is not how do we stop AI, but how do we actually channel it in the most productive ways? And how do we think about both risks as well as opportunities?
Thank you, Steve. We have some comments on just thanking you for your great lecture, and then they're inspired by this lecture. So I will just take the last question, and that is about bias AI in the political part of it. Some of the countries, they are also worried that these technologies will be used against for the political part of it, especially in the bias, because it's very difficult to see that what is the actual intentions behind that. So how do you see that political bias in AI?
Well, powerful as AI is, one of the challenges it has with language is the human capability to use shades of meaning, to use metaphors. We have ways of speaking with exaggeration when we don't mean literally what's there, and machines have a hard time trying to do that sort of thing. But what it can do is capture words and phrases, and we know already that it's a challenge for human beings, and that national security agencies, it's well known, are are listening in for particular words that might suggest terrorism or extremism and those kinds of political things. And whether they got it right or not, somebody gets then identified and more attention is paid to them. We have that risk. And I think those are all questions that are going to require societal engagement. Pre-COVID, in a normal year, I would travel quite a bit around the world. And I know that across the globe, different countries and societies value what we Americans call privacy, in the sense of nobody should know anything about what I'm doing. We view that as very important compared to, for example, social safety and public safety. There are other societies that put a greater emphasis than we do anyway on the other. So I think this is not one where there's one size fits all. I think we all need to ask the same questions to protect, again, the dignity of human beings able to select the world in which they're going to live, and use AI as a tool, but not let AI simply end up in the hands of people who happen to be in power today to instantiate and reduce the opportunity for changes that societies seek.
Thank you very much, Steve, for your time and interesting talk, and then answering all the questions. I would also like to thank Sergey Bolshakov. He's the head of public affairs and government affairs in Microsoft Russia. With his support, we were able to do this session today. Thank you very much for your time. And thank you all the participants who have attended this session. We have recorded this session, and this will be available on our YouTube channel in a couple of days. Thank you very much, Steve, for your time, and thank you, everyone.
Thank you. It was a real pleasure putting this together in the conversation. Thank you.
Thank you very much. Bye-bye.